Hello and welcome to Healthy Seminars. My name is Lauren Brown, and we are continuing with a lecture series with Dr. Bill Bengston. Our lecture series is called Lessons from the Lab, a selection of energy healing experiments. And this is part 2 of this lecture series. And if you missed that, I'm just going to bring this up on the screen. I'll share this for you, but the replays are on healthyseminars.com. You just go to resources, or even better, go to healthyseminars.com/Bengston, and you'll see the replays. So if you scroll all the way to the bottom, here's part 1. And after this is recorded, part 2 will be up here as well. And it's a good chance for me to actually let you know that these are really what we call prerequisites. If you're going to do his workshop, Bill's doing an online workshop for 3 days. I did this in person. I've used this in my practice, and I encourage you, recommend you to look into this workshop. It's fun. As you can see, it's a fun and informative lecture, and it's something great to bring to your practice. And those dates are June 27th, 8th, and 11th. And you just click on this link, or you can go to laurenbrown.com and you'll find the information on this workshop. And just check out our healthyseminars.com/resources. We have a lot of free lectures still coming up. We keep adding. We also have CEU, PDA, the CME approved for acupuncturist, functional medicine, naturopath on our website here. So you can check out our calendar of events under resources, and you can see what's planned for June and July, and the list goes on. So I just want to let you know about that. And again, if you go to healthyseminars.com/Bengston, that's where you'll find the replays for part 1 and part 2. And there's also a link to take you to find out all the information that Bill's going to do during his workshop, which, Bill, I invite you to share with people as well. Can we bring up the disclaimer slide, and then we'll get up Dr. Bill's PowerPoint presentation. Again, a reminder that this is for educational and entertainment purposes only. This is not meant to be interpreted as medical advice. If you have a health condition, please seek out a healthcare provider. Again, this is for educational purposes only. Thank you. So again, if this is your first time you've come to this lecture, please, after this, watch part 1. And if you're watching this as a recording, pause here and go back and watch part 1, because this is a continuation of part 1 and to go into part 2. And I'll pass the microphone now on to Dr. Bill Bengston. And Bill, at some point, maybe if people are interested, let them know what the plan is for your workshop. And also, for those that are here at the end, there's Q&A. You can raise your hand digitally during the live webinar. So you can raise your hand, not in the computer screen like I'm doing, but down at the bottom, there's a place to raise your hand digitally, and we can give you mic rights to ask Dr. Bill Bengston your question. I think that's what I wanted to say about that. Anyways, Bill, the mic's yours. I'm interested in hearing part 2 of this, and I'm here moderating, so if there's any urgent questions, I'll interrupt you. Otherwise, at the end, we'll give people mic rights as well.
Thanks, Lauren. Welcome, everybody. I've got some contact information up here. I'm going to prattle a little bit tonight, prattled a little bit a few days ago, and probably there's a couple of questions which may arise even after we shut down the talks, and you'll have a couple of questions trying to figure out, do I want to take this stupid workshop? Do I want to, here's my question, does it work for this? Does it work for that? And by all means, feel free to look me up. Come to the website, contact me, send an email, et cetera, et cetera. I'll have this slide up in some form or another, the contact information as we end for the night. I have to get this out of the way because Lauren once again says he will mute my mic if I don't thank him and tell him that all good things come from him. So that's his most humble statement, I think, Lauren, that you said, yes, I am. Nonetheless, let me move on. So what I want to do is take a couple of minutes to just kind of go do the greatest hits of the last talk, which was last Sunday, and obviously not to any depth, but just kind of a quick brush through, a reminder. This slide was up there at one point, and I suggested that in the zillions of years that I've been studying healing, these little bullet points are the areas that I've focused on. So they're generic kind of things. So the first bullet point, I'm looking at the parameters of healing. What makes it work well? What makes it work not so well? Are there states of mind involved? Does distance matter? Things along those lines. And some of these we'll cover tonight. I'm interested in the physiological correlates of healing, the second bullet, what happens to the healer, what happens to the healee. The third bullet, investigation of teaching efficacy. I mean, obviously that's central to what I'm doing here. What are the best ways to get across the ideas and to get people up and running doing the techniques? This is during the workshop. So during the workshop, I'll be drilling, practicing you and doing all these kinds of horrible things, trying to get you to up, run, and learn the method. The fourth bullet, the development of a theoretical model, is the scientific motherlode. That's the goal of goals. Can we put together a model that makes healing make sense and that makes healing predictable so that I can predict the outcome based on my understanding of the way the world works? And I told you on Sunday, and I'll tell you again now, not much has changed since Sunday. So in the last 4 days, I've been a slacker. I have not come up with a grand theoretical model for how the world works. I had some really rousing debates with a friend of mine in Germany this morning, and he was claiming that he came up with this model of how parts of it works, and then of course, it's not hard to rip it down, and I came up with an idea and he ripped it down, but we're poking there. Let me tell you that right now, that for the interest of being straightforward, and also for the interest of being careful when you're out there taking courses and workshops and such, let me tell you that nobody that I'm aware of, including me, can really explain how this crazy stuff works. I have lots of data. I'm going to show you some of the data tonight. I showed you some of the data a few days ago. I have much more data that we won't get to here. But really, in terms of understanding how it happens, no, not yet. It would be nice, and if you take the workshop and you can figure out how it all works, I'll give you extra credit. The last bullet is because I've been doing this for about 70 years, and I'm only going to do it for about another 70 or 75, and then I'll go on partial retirement. Since if a theoretical understanding of how the world works is not imminent, I'm now trying to make practical stuff. And so I've been working for the last couple of years on capturing and reproducing healing without the healer. And the general idea here is, if I can capture it, if I can put it figuratively in a bottle, if I can stick it in a battery, if I can somehow store it and bring it to bear, I can make this scalable. So even if those of you who take the workshop, you're going to learn my healing method, it's reasonably interesting, lots of stuff will happen, and you go teach other people how to do it, and they go teach other people how to do it, there's still an inexhaustible supply of people in pain. And the question is, in my mind, how do you scale this? How would we do it? How could we treat, for example, 100,000 people, 200,000 people? Is there a way to scale this? And I'll just tell you now, without details, yes. I've found some really, really interesting data. I still don't understand how it works, but I found some seriously interesting data which will point in that direction. So I will not go into this in any detail, but if you're interested in stuff for a layperson, a book, this is not a sales technique. If you want to hear my story, it's on the left side. If you want to learn how to do the technique, it's on the right side. I don't keep things proprietary. I don't have little secrets that I wouldn't tell you this until you come back and take a workshop again. I publish everything that I have. Most of the stuff that I publish is not meant for a general audience. It's rather academic, geeky kinds of stuff. And if you are interested, at the very bottom of this slide, and you go to bengstonresearch.com, there's a way to get to research. And if you want to be a geek, I've got about 35 geeky publications. I actually don't know the real number, but it's at least 35 publications in peer-reviewed geeky kinds of journals. So if you want to go geek, go to the research. If you want it in English, books and things like that. So I promised 8 propositions during the course of these 2 talk days as well as a workshop. And it's a lot of stuff. And we only got, and it was by design, we only got through number 1. The proposition, cancer can be cured using energy healing. And I phrased and we're going to get through all 8 eventually. I'm hoping to get through number 6 tonight, and 7 and 8 during the workshop. But I phrased this, the proposition is a statement that I say I can back up. And this is the same area that's interesting if you were a clinician trying to help a patient. So I'm saying cancer can be cured using energy healing, except I don't think it's energy. Cancer can be cured using energy healing. If a patient walks in, the first thing they're going to say, can you fix me? And it doesn't have to be cancer. It could be, I have a wart. It could be, I have anxiety. It could be, I have a bad back. It could be, I'm depressed. It could be, I have Parkinson's. It could be, you get the idea. So I'm using cancer only because I've done so much research on cancer. But don't get hung up on the cancer part. It's just interesting. Fill in a different disease, and we can talk about that down the road. So I'm suggesting cancer can be cured. If you are a patient, that's a statement that is in response to what would be on their minds. Can you fix me? And I'm saying, yep. If you're a researcher in a lab, could I, under controlled conditions, fix cancer? It's the same question as proposition. It's the same as proposition 1. So proposition 1 is a statement, but it could also be what's rummaging around in the minds of a basic researcher in a lab. It's also rummaging around in the mind of a clinician who's trying to help a patient, and it's also rummaging around in the mind of the patient. So if you can be multitasking here and think of yourself as a patient, think of yourself as a clinician, and think of yourself as a researcher, proposition 1 is interesting. And I'm simply boldly saying, yep, cancer can be cured. And you can see how that would apply to basic researcher, clinician, or a patient. From proposition 1, and this goes back to a couple of days ago, just very, very quickly here. I think in very simple terms, and what I do is I go into the lab. I don't really do much clinical work anymore. I go into the lab. I take a model that's already very well understood. The cancer model in a mouse is very well understood. We know what happens when the mice get cancer. We know everything about it. We know how to predict the outcome. We know all this stuff. Traditional biologists spend their time studying these mice, and they publish papers and they share information and they do all that. And so I go in and I steal the model. What do you know the most about? Well, it turns out biologists know the most about this mouse and this cancer. This cancer that you're looking at, you can't tell, but it's a mammary cancer. And so in this particular mammary cancer, if you're injecting a mouse with cancer, no mouse has ever lived past a month. And I say no mouse has ever lived past a month. That's in over 2,000 publications. No matter what you do to the mouse, you radiate the mouse, you give the mouse chemotherapy, you give the mouse aspirin, you give the mouse a lot of food, you take away the food, you do whatever you do, and nothing happens. This mouse does not live more than a month, no matter what you do. So this is a given model, it's fixed. I come in the lab, and that's me in the lab. This is me at Brown University. Lauren, I don't know if is that named after you, Brown University? It's yeah, okay. So he picked one of the Ivies, you know, and I think they asked if they could turn it into, it used to be called Lauren College, now it's Brown University. And so we come in, and what you're looking at there, you can't tell, but I'm actually doing the technique that some of you folks are going to learn in the workshop. And then I put my hands on the cage or around the cage, and then we find out what happens. So we know what happens if you don't. You got an ugly mouse and the mouse dies, and it's not a good way to go. If you put your hands on top of the cage or around the cage, I've interjected a single variable, and then the question is, what happens? And so what happens is the mouse develops a tumor. The tumor, this is a very short version, the mouse develops a tumor. The mouse developed a blackened area on the tip of the tumor. The blackened area opens up into a big ulceration. It looks like the mouse is suffering. It's not. This ulceration, you'll see this in later pictures, this ulceration has cancer in it. If we do histology of cells within this, you'll find viable cancer cells. So it's not a question whether the mouse had cancer. And then the thing implodes, and then the mouse is cured. So, short version, this has been done many, many times, 18 different times in 4 or 5 medical schools, a bunch of other independent labs. There's not really much question anymore. Even a skeptic such as myself has to throw in the towel and say, cancer can be cured. And so my first bullet point here, there is sufficient evidence, experimental evidence, and there's sufficient clinical experience that this is a closed case. In other words, if someone comes around and says, I wonder if it's possible to cure cancer, that means they don't know what's out there, because the answer is, yes, it is. There's sufficient replications getting the same thing in multiple labs. There's hundreds of mice cured. There's hundreds of people cured. There's not a question about this anymore. So even I, the card-carrying skeptic, go, I give up, yep, you can fix cancer. Now, that doesn't mean, second bullet, that anybody who claims to be a healer can do this. And it doesn't mean all healing techniques are the same. And it doesn't mean a whole lot of things. It just means that, at least in cancer, there is a way to fix cancer in mice, in people. We can measure it in a lab. We can measure it out in the clinical world. So once again, second bullet, really important. Doesn't mean all claims are real. Doesn't mean everybody's saying what they can do, they can really do. There's not that much evidence out there that I've been able to find on a whole bunch of healing claims. So be careful. Once we can say cancer's cured, it no longer is an interesting question to say, could you do it one more time? Because, how many times you need this? If you've got 18, it's enough. And so the last bullet, we've got now what I call second order questions. Now that we know it can happen, how does it happen? That's the mother lode. What makes it happen? What varies its outcome? So those questions matter. Meaning, how long does it take to treat? How many times should you treat? How often? You can see this is going to come in to be the question on the patient's mind. First, they come in, can you help me? Okay, once we get that out of the way, will I stay helped if you can help me? How many times do I got to keep coming back? When is this going to work? You can see the idea. I'm calling these second order questions. They're not a question of what's the outcome? It's the question of how do you get to that outcome? So what are the questions about dose? What are the questions about mechanism of action? What are the questions on variation in response to healing, et cetera, et cetera? These become central, and that's what I want to talk about today. A small selection of, here are the second order questions. We're moved past, yep, healing can be fixed. That's nice. Let's move on.
Bill, a question on Proposition 1 that healing can be fixed.
Yeah.
This is a carryover from last week, is if this has been replicated, has this been brought to the conventional system that deal with oncology? Like, is this going mainstream? Have they been receptive to this? If you can show that cancer is being cured, how is this happening in the mainstream or not happening?
People aren't sure what to do with it. That's the short version. It's an unbelievable claim, but I've got evidence to beat the band. I can tell you, I've spoken. I do research in medical schools, Brown University Medical School right now. But I've given talks in medical schools. I've given talks to departments of oncology in medical schools, and here's how it's received. The really short version is this. And I'm thinking of a talk I gave at the University of Connecticut Medical School, and they booked it for a room of about 50 people. and about 200 people showed up. And there, among the 200 people, there was at least, I'm making up a number, but the best estimates are at least 75 practicing clinical oncologists, plus a whole bunch of experimental oncologists. And so we had experimentalists, we had clinicians, and I had all sorts of data on humans, I had all sorts of data on cells, I had all sorts of data on mice. And they, of course, knew the mouse model, because everybody knows the mouse model. And they spent, I don't know, 3 hours or so trying to cut my knees out. And at the end, they said, we give up. You know, the experiments are done right. You got a handle on this. Yeah, you cured cancer. And you're curing cancer. And then they all left. I mean, that's what happened. They all left. Because now, what do? You know, and I have taught this technique to physicians. So I'll just stay in Canada now. I've never done it in the Western provinces, but I've taught in Ontario to a group of physicians, and I taught in Quebec to a group of physicians, and all of them were like all a tingle. And I'll tell you, without names, that they all said, if we practice this, we'll lose our licenses. Now, the part I definitely won't tell you their names is, they've come back to me privately and said, thank you, I'm curing my patients. So we have two different questions. One, does it work? The second thing is, are we allowed to use it? And that really becomes the complication. And we need to deal with those kinds of questions in some detail in the workshop itself, because if you're going to go out and do this, you're putting yourself at professional risk. And that ought not to be minimized. So one, I'm moving on from, and today, well, it's night here, we want to go 2 through 6. I don't think I'll be able to make it past 6. And 7 and 8 are seriously interesting, but I don't think we'll make it here. But they need to be covered in the workshop because, for example, 7, healing is an autonomic response to need. It will go to the question of, when we actually start doing hands-on stuff with each other, how present should you be? How much should I pay attention? All those kinds of things. And some of the data is reasonably disturbing, but it's repeatable data. And finally, in 8, which I won't get to, is how do we make a battery? You know, how do we store it in a little gizmo and reproduce it without the healer? So we go not as long, obviously, as 1, but we'll go flying through some of these. I'll spend a little bit more, the most time probably on 6, which is very interesting, not only experimentally, but also clinically. So let's go, and we'll go trucking through now. Patient comes in, can you help me? Second question, if I'm feeling better, is it gonna last? A way to put that in terms of cancer is the difference between remission and cure. So remission means the stuff, the symptoms, the indicators are gone, and then you got in a little parentheses, so far. If you're cured, they're gone. And I used to call this remission of cancer until finally a biologist, who you'd know the name, but a biologist said, would you stop saying remission? You're not remitting these mice. They're cured. And I said, okay, I'll try to use cured. It seems awkward, and I know that you can get into a lot of trouble, certainly in the States, by saying I've cured. You're not supposed to cure. You're supposed to help. You're supposed to augment. You're supposed to assist. You're supposed to do a lot of stuff, but don't say the C word. It's dangerous. But I'm saying here, proposition 2 to question 2, once cured, cancer is cured for life. And on this, I also have experimental evidence, and I have clinical experience. Once again, experimental evidence is much different than clinical experience. Clinical experience means, what happens when I do this to a patient? Experimental evidence is, I'm controlling the environment and I'm doing this to cells or mice or something like that. We don't, for the most part, experiment on people. But so experimental evidence is hard lab data. Clinical experience is softer, and it's harder to do, frankly, than the experimental evidence. So I'm suggesting healing does last. Once cured, it's cured for life. And I can do this real quick. In hundreds of mice, we've never had a recurrence of cancer, and we keep them their entire life. The second bullet, I don't know if you can see my pointer. Mice are immune to repeated re-injections of the cancer. Now that's reasonably interesting. So once the mice go to cure and there's no more cancer, we can leave them alone and they'll hang out and do whatever they do, and they'll spend the rest of their life and no cancers ever come back. But we're a little more aggressive than that. What we do is we actually re-inject them with cancer. And it turns out once they're cured, they can't get cancer again. That's reasonably interesting. And if I skip then from the second bullet down to the last bullet, where I've got speculation, there may be an immune factor going on here that can be transferred. And it's not entirely speculative. You're going to see some data in a little bit where since I'm very conservative about claims, I'm going to still call it speculative. There's not sufficient replication on the last bullet. But I have a bet with an immunologist that what's going on is what happens in healing, at least healing when you're treating cancer, is that the cancer, you're not treating the cancer itself, you're giving the body what it needs. And what it needs, if you have cancer, is you need a boost to the immune system. As far as I'm aware, nobody has ever been found who doesn't have cancer, meaning in their body they have cancer cells. I mean, in their body, you got a whole bunch of stuff. Now, a good chunk of you in your body, you're going to have COVID. Don't worry about it. You got a little COVID, you got a little this, you got a little that, you got a little of the other. You also have cancer cells. But a healthy person has an immune system that mops up stuff, including cancer cells. Someone who has the disease, cancer, has gotten behind the 8 ball of their immune system. And so I suspect, it's speculation a little bit, that what we're doing in healing, in cancer anyway, is we're giving the immune system the information it needs, not energy. We're giving it the information it needs on how to beat whatever it has.
Bill, there's a question. The injections that you give, is it the same cancer or a different cancer that they're being immune to?
To date, we've only given the same cancer. I know what the question means. Is it a blanket immunity, or is it immunospecific, as many immune responses are? And so far, we've only given re-injections of the same cancer. It's this is very easy to test by just giving a different kind of cancer and seeing what happens. We just haven't done it yet. So I have kind of a big scroll of questions that I haven't addressed yet. This is among them. I don't think that healing could function as a vaccine, a preventative vaccine. This is speculation on my part. I don't think healing would function as a preventative vaccine. And what I mean by that is, let's say we take a healthy person and we treat the healthy person. I don't think anything's going to happen to the person who has no need. And I suspect that you couldn't use this prophylactically, that healing rather stimulates the information necessary to take care of the problem, to go back to homeostasis. So no mouse has ever had a recurrence. Mice are immune to repeated re-injections of the same cancer. And as far as I know, no person has ever had a recurrence. This has to be taken with some grains of salt, because we've been doing this for a zillion years. We've done a zillion people. I don't know what happens to them. You know, the mice, they're in the cage. I know what happens to them for the rest of their lives. I don't know what happens. So somebody we treated, I'm making this up, somebody we treated 25 years ago, did they ever get a recurrence? I mean, the answer is I don't know. You might make a case that they probably would come back, but if that happened, but you know, the bottom line is I don't know. So this is called, among other things, the file drawer problem. I never know what happens clinically. You go out and the person lives their own life and makes their own decisions, and I don't know what happens to them. I do know people who have been treated 25 years ago, but I don't know of any person who's ever had a recurrence. Doesn't mean nobody's ever had a recurrence. It means that I don't know about them. And the fourth bullet, if I can find my pointer here, the fourth bullet, the cell line will no longer seed forward, is very close to my last bullet speculation. And what happens here you get a mouse, and you get a mouse from a lab. It comes from Jackson Labs. It comes from the National Cancer Institute. It comes from someplace that supplies cancer. And very often, but not exclusively, sometimes the cancer comes in a mouse. And you take the tumor from the mouse and you grind it up, and you do this and that and the other thing to it, and you got a bunch of cancer cells, and you inject them into the next generation. They in turn grow the cell line, and then at some point you harvest those cells and you seed it into the next generation, and the cell line goes forward. And so there's cell lines which have been going on for decades. Once we treat a mouse, the cell line dies, which is interesting, meaning it no longer seeds forward to the next generation. And so this is consistent with some immune factor, but we still don't understand really how this works. But it's something to, I think, pay attention to. Person comes in, can you fix me? Will I stay fixed? How many times do I have to come for a treatment? Well, this is proposition 3, which can be phrased in the form of a question. How much treatment is necessary? The question for the experimentalist will be, is there a dose response? The question for the clinician is, how many times do I have to treat? The question for the patient is, how many times do I have to treat, and how long do I have to get treated for? And so this is, in geek terms, this is the dose response question. How much do I need to take at what frequency? And so on this, I have no clinical experience because I've never experimented on people to see how little I can treat them before they start to die. Now, I do that with mice. So we know if we give this amount of treatment at this frequency, we know what's going to happen. What if we cut back in the time? If we cut back in the length of treatment? So instead of treating the mice for an hour at a treatment, what if we treat them for a half hour? Instead of treating them 3 times a week, what if we treat them once a week? What if we treat them 5 times a week? And this goes to a really important clinical question, and that is, if you're a clinician and you're out there and you're treating patient after patient after patient, how long do you treat a patient? I mean, the way to keep it nice and neat and clean is to have scheduled times. So my next patient will be 45 minutes. I'm making up a number. My next patient will be 45 minutes. Well, what if the patient needs more than 45 minutes? Tough. You had your 45 minutes. Get out of here. I mean, it's an interesting problem. So the question of dose is, here are the bullet points. The amount of treatment needed to remit any type of cancer is unknown. I can't make a prediction on an individual mouse. I can't make a prediction of an individual person. I can't make a prediction of an individual cell. Too much variation. We statisticians phrase that unexplained variance, which is code for, I don't know. Give it a nice title, but the answer is, I don't know. And there's a wide variety of clinical responses that exactly mirrors, that's my second bullet, that exactly mirrors what happens in a lab with the mice, which is also reasonably interesting. So, for example, if you're working clinically and you have a couple of patients, we can assume there's going to be differences between the patients. And you have 25 patients. Well, the 25 patients, each is its own individual and does with all that implies. How are you going to make a prediction with that? What I do is I take identical mice. They're identical mice. They're essentially, but not literally, clones of one another. They're stamped out, and I put a number of these mice that are from the same litter, the same genes, the same everything, into the same cage, and then I have somebody put their hands on the cage. So everything about each one of these mice is identical, including the healer that's supposed to be the therapist. One mouse in the cage will take X amount of days. and its companion in the cage will take 2.5x. So one mouse takes, I'm making up a number, 20 days. Its companion, which is an identical clone, not really, 2.5 times 20. Now, what makes one go so fast and one makes one go so slow? And the answer is, hell, I don't know. Unexplained variance. So I can't tell you the amount of treatment needed to remit any type of cancer. I can't predict the outcome of an individual case. I can't. This is too hard. I can tell you in the second bullet, the wide variety of clinical responses mirrors what happens to mice. In other words, I can have a bunch of, we'll call it breast cancer patients, and one will take apparently X number of days to be cured, and the other one will take, another patient will take 2.5 times as long as X. Now, when you get to people, and this drives me up the wall, when you get to people, you get all bent out of shape and you turn into Sigmund Freud. Here's a hint, never turn into Sigmund Freud. Why'd you take so long when your companion took so little? You must be deficient somehow. What's the matter with you? And you start blaming the patient. You want to see me go crazy, start blaming the patient. And I tell you that you get the same variation in cell cultures as you do in humans. You get the same variation in mice as you do in humans. I can tell you that in the aggregate, if we're looking at clinical responses, in mice as well as in people, the more aggressive the cancer, the faster it'll be cured. In the aggregate. So a fast-growing cancer will go away much faster than a slow-growing cancer. But a fast-growing cancer still has the internal unexplained variance. Some of the fast-growing cancer goes away quick, some not so quick. Some of the slow-growing cancer goes away not so quick and really not so quick. In the aggregate, a fast-growing cancer is faster to treat, and in that sense, you could say easier to treat than is a slow-growing cancer. You want a good, aggressive cancer if you want a quick, down and dirty cure. Slow-growing cancers, they come in slow, they leave slow. The energy in what we call energy healing is not the healer. The energy is the condition itself. And the energy comes from the healee, not the healer. You are not giving energy when you do energy healing. If there's not a lot of juice in the condition, it comes in slowly, it leaves slowly. If there's a lot of juice in the condition, it comes in like a freight train, and it leaves like a freight train. The third bullet, remission rate might be related to mass or metabolic rate. So we've done this in large research labs with all sorts of different kinds of animals. If we take an entire cancer lab and cure the entire lab, which we've done, sometimes to people's consternation, little mice go first, bigger rats go second, and as the size of the animal, as the mass of the animal goes up, the speed with which it's cured, it goes slower. Now size is also related to metabolic rate. So we don't know whether this is metabolic rate or it's mass. And I tested this at University of Connecticut Medical School, since apparently rats take longer to cure than mice. Is it because the rats are bigger than mice and therefore have more mass, or rats are bigger than mice and therefore they have a slower metabolic rate? And so what we did is studies of rats and then compared it to the same number of mice that would equal the weight of the rat. And it turns out it's not mass. It might be related to metabolic rate, but it's not mass. And one of the biggest things, if you're looking at empirical problems, is bullet 4, is each treatment dose equal? You know, we're out there going, okay, let's try treating a half hour a day. Let's try treating an hour a day. Let's try treating once a week, 3 times a week, 5 times a week, 7 times a week. you know, you get tired too. So are you at the end of the day the same as you are in the beginning of the day? In my case, I'm better at the end of the day because I don't wake up quickly. But for most people, it's the opposite. They get tired later. Is each dose equal? You know, a human, you flip on a switch, I'm going to give a treatment. It's not exactly parallel to running an electrical switch or you're turning on the lamp. It's probably a little more complicated than that. In bold on the bottom, the only known predictor of the speed of cure is the number of mice. This is startlingly important for clinical as well as experimental work. And this will come into, remember this when we get to proposition 6 today. The only known predictor of the collective speed of remission is the number of mice. So I'm not contradicting my earlier bullets. I never know whether this mouse will get better faster than that mouse. I never know whether this person will get better faster than that person. In the aggregate, faster growing cancers leave faster, but I can't make an individual predictor. So we're talking aggregate, a gaggle of mice or a gaggle of people. The more mice in an experiment, the faster they all get cured. You really need to spend some time on this, and I'm going to come back to clinical applications in clinical practice. In other words, in simple terms, if you've got 10 mice in an experiment, that's harder to cure than 20 mice. The simple fact of more mice, they collectively get better faster. This is also speculatively the case in humans. And we'll talk down the road. Is there an immediate response to healing? Patient's question there is, when am I going to be fixed? I was in pain, I'm still in pain. You know, what's the matter? I had a tumor, I still have a tumor. What's the matter? I had arthritis, I still have arthritis. When is this thing going to work? And my proposition 4, in response to the question, is there an immediate response to healing, is that healing occurs non-linearly. It occurs in bursts. And for this, I have an enormous amount of experimental evidence, and I also have an enormous amount of clinical experience. One of the reasons this proposition is important is because we want to get away from magical thinking. Person comes in, oh, it's healing, you know, it's hocus pocus, it must be, what's the S word they use? Spiritual, it's this, it's that. It might, you know, magic will happen and fairy dust will fall from the ceilings and instantaneous cures occur. Well, instantaneous cures do occur, but not very frequently, and they scare the hell out of you. And I have no idea how or why they occur. But healing does not proceed linearly. It doesn't diminish it in a straight, if it's pain, it doesn't diminish in a straight line. If it's tumors, the tumors don't, each time you give a treatment, it doesn't just keep going down. There's bursts, and this is really important and has tremendous amount of clinical implications. So I'm going to show you some cell medium stuff, and this is the medium in which cells are grown. It's just standard off the shelf lab stuff. You take a bunch of nutrient, this is the environment, you pour a bunch of cells in, and you have a living, breathing in vitro cell colony. I mean, that's the short version. But the cells have to be living in some nutrient. This is the nutrient. We treat the nutrient, not the cells. We treat the nutrient and give the nutrient to the cells. So here's treated nutrient, and we give it to cancer cells. Here's untreated nutrient. We give that to cancer cells. What happens? So I'm not going to do this in a lot of detail. On the left here, if you can see my little arrow here on the left, this is a control group of cells. They're not getting treated medium. Over here is treated with treated medium, and this is a different dilution of the treated medium. But on the right are the treated medium, and on the left are not the treated medium. So these are the controls. Now you can see, we don't have to give you actual stats, that they're all pretty much the same. And so what happens to cells sitting in a cell culture for a week and then we compare what kind of cell nutrient you're sitting in. This has been treated or this hasn't been treated. Well, there's no difference. Second week, sudden bursts, explosion of the treated medium. So if I were to average this out, and I don't have that here, this is just a quick visual, and this is on the Y, we've got a different metric, but this is the controls and this is the treated. And you can see this is much, much, much stronger, higher. And what I'm really measuring here is cell growth. And so we're measuring cancer cells in treated medium and cancer cells in untreated medium. Short version, cancer cells in untreated medium go about their days, hanging out, watching TV, reading a book, and doing whatever they do. Cancer cells in treated medium, suddenly, after a certain exposure, think after a certain dose, they explode. And by explode here, wildly accelerate. We have on average, this is done at University of California in San Diego, we have on average a 600% increase in cancer growth. That doesn't need statistics to tease out an effect. Now, if you're treating cancer cells, who's your client? It's cancer. What is cancer like? It likes to grow. My point here is two. First thing, not really related to this proposition, the client's getting what the client wants. Second thing is nothing happened for a while and then suddenly it happens. And I can up this to mice. These pictures are startling. And these could be the most startling pictures I have. This is a mouse 22 days after injection. And you see it's got an ulceration. Histology will show cancer cells there. But here you can see that the mouse is bright-eyed and bushy-tailed. You can see that the coat is looking good. And I'm going to show you this mouse, which doesn't look like it should be good. And it does have cancer, and the tumor has ulcerated. I'm going to show you the same mouse 6 days later. This is a picture of the biologist pulling back the fur to try to figure out where the cancer was. And if you don't pull it back, remember, none of these mice have ever lived past a month. If you don't pull it back, by a month, it's completely gone. There's no cancer in this animal at all, and it lives out its full lifespan. It lives out its full lifespan, and it's immune to further reinjections, at least to the same cancer. So again, because this is kind of cool, nothing's happening. Imagine being a patient. So this is my clinical take-home message. Imagine being a patient, and I got a tumor. And so you come along, I got a tumor, you come along, you're doing whatever you're doing, and I come back for the next treatment, and the tumor's bigger. And then you come back the next treatment, the tumor's bigger. And you come back the next treatment, and the tumor's opening up. Now, what kind of crazy patient would keep coming back? And then suddenly, and this happens the same thing in people, it's gone. Now, clinicians, and I'm assuming most of the folks listening are more clinically oriented than me, put this into a human model. How in heaven's name does a human go through this? No pain, but come on. You don't think your friends are going to be saying, please go get help? You're dying? You're not dying. This is, for all practical purposes, a cured mouse, which eventually is cured, and it's cured for its entire life. So sudden bursts in cell cultures, sudden bursts in animals, sudden bursts clinically. So across cages, this is what happens. Now we can talk about bursts. I'm just getting mindful of time. We can talk about bursts, and we can also look at things like what happens to the physical space in a room. And I'm going to do this pretty quick. This is too geeky. Let me just do this this is background geomagnetic pulses going on in a room. It should be chaotic with maximum entropy, chaos. If we treat a mouse and we run a probe in a room, it turns into the upper wave. And what you're seeing is, it implies the insertion of information into a system. And what you're seeing is a reduction in entropy. The same thing happens if we run random number generators in a room and we have cancerous mice and we just treat the mice and the random number generators are someplace else in the room. They no longer generate random numbers when we're treating a cancerous mouse. If the mouse has no need, nothing happens to the random number generator. But the analog here, it's an indirect analog. The analog here is that we're inserting information into a room. I think that's what healing is. I would very much like to know what the information is, but all indications are we're not doing energy healing, we're doing information transfer. And maybe later, but probably not today, I can speculate about what might be carrier waves and things along those lines. Patient comes in, when am I going to get better? You know, this, that, and the other. And of course, your answer is, I'm not sure. I don't know. How many treatments? I don't know. When will it? I don't know. You know, then I go to the theoretical, nobody knows. And we don't know enough to even remotely make a prediction. When I'm being treated by you, doing this crazy technique, can I also take fill in the blank? And the analog here would be, say you're taking statins. Well, if you're taking statins, statins will come with a label that'll say, don't eat grapefruit. So statins and grapefruit aren't a good combination. Most of the stuff that we take in conventional medicine, and most people have a boatload of things that they take, most of the stuff we take in medicine, nobody knows the interactive effects. It's too complex to model. And so you're taking this because you went to see this doc and you went to see that doc and you went to see this therapist and you went to see that therapist and you went to see, and they said, and they said, and they said, and they said, and you're putting all this stuff into you in one way or another. And is that okay? And well, some people out there in healing land have, again, make the crazy assumption that there's something mysterious, well, sacred about healing, or something spiritual about healing. And anything that's spiritual, of course, has to have a good outcome. Well, no, it doesn't. I mean, I think grapefruit's spiritual. But if you're doing it with statins, it's not a great combination. If you got statins and grapefruit, my recommendation would be dump the statins. I'm not giving medical advice. I'm following what Lauren said earlier, but I'd rather take a grapefruit than a statin. In the winter, I can't wake up without a grapefruit. So what can this be combined with? Now, in the conventional world, nobody knows. It's too complex. It's also interesting here, but I'm not going to make an assumption. If healing is real, and I think by now I've got enough evidence that healing is real, then it probably has consequences, and it probably has interactive effects, and it's probably something you want to pay attention to. And so I'll just say, in these two bullets, clinical failures have all been associated when combined with conventional treatments that kill. There are treatments for cancer whose job is to kill, not the patient, but let's take radiation. So we've got a beam of radiation focused on a particular cluster of cells. That radiation is not going to increase the health of those cells. The purpose of the radiation is to kill. When we, at least in the States, declare war on cancer, we're not kidding. We're bringing in the artillery. We're going to beat the hell out of this thing, and we're hoping that you outlive it. But you're going to be in the middle of a war, and we hope to win. All I'm trying to say here, I'm not giving medical advice, is that's the approach. But we've had patients, human patients, who have been in the war And the ones that we have not fixed, and there have been people we haven't fixed, have all been associated with combining healing and killing. And so if you just think conceptually, because I put it in stark terms, should healing be combined with killing? You know, I mean, when I put it that crassly, it sounds silly, but that's really what you're doing. So I'm going to go to my healer and I'm going to go to my killer. One's trying to do this and one's trying to do that. Is that good? Now, if you're a patient, it's certainly understandable that you want to throw the kitchen sink at a problem. You know, I'll try this, I'll try this, I'll try this. You know, I'll try your nutritions, I'll do vitamin C, I'll take intravenous this and that. I'll you know, do whatever you want to do to me. Just let's throw the kitchen sink at it. I'm suggesting to you that that may not be a good approach. It's understandable from a psychological point of view, but it doesn't make any conceptual sense as a therapy. I have not, this is on my list, I have not experimentally verified that. This is incredibly simple to do. So I can take a mouse, radiate it, and then give it cancer, then treat it. I can treat it, then give it radiation, then I can, you know, and do all the permutations. It's not hard to do, meaning it's not hard to map out. It just hasn't been done yet. So all I have here is clinical experience, and I'm always going to be cautious if all you have is clinical experience. This has not been done under a controlled setting in a lab. Needs to be experimentally verified. And finally, as far as I think we'll get tonight, and this is seriously interesting, healing is associated with resonant bonding. And for this, I have both experimental evidence and clinical experience. Now, resonant bonding is a term I made up that really means connection. And connection also has the flip side of that, disconnection. And I don't need to explain this because if you've been alive more than a couple hours, you've all had the experience of connection and disconnection. And sometimes you have connection and disconnection from the same thing. So sometimes people call this entanglement. And then they go all a tingle running down the road saying it's a quantum effect. Quantum is the single most misused word I've ever heard in my life. Quantum physics, I don't know how many people out there have studied it. It's a matrix algebra, which is a mathematical formalism that produces incredibly good predictions, and no one understands the math. And so the English translation is entanglement. This photon and that photon bounce off each other and then they're entangled. And that's been experimentally verified. I'm not putting it down, but you call it quantum entanglement and then you shorten it either to it's a quantum effect or it's an entanglement effect. Both are misused. Entanglement is a one-directional process. Once you're entangled, you don't disentangle. So if this atom is hooked up to this atom and this atom goes flying off into the sunset, they're still entangled. They're entangled next week. They're entangled next year. They're entangled. They can't escape each other. Resonant bonding assumes fluidity. So your experience when you say, oh, I'm connected, it's a quantum thing, no, it's resonant bonding. On Monday, you love your dog. On Tuesday, you hate your dog. So on Monday, I felt close to my dog. On Tuesday, I hated a little twerp. Now, what happened there? It's the same dog. The dog didn't change Monday to Tuesday. But on Monday, you feel connected, and on Tuesday, you feel disconnected. That's bonding. Healing, and that's not entanglement, obviously. So all these experiences of connection and spiritual connection and all that stuff, I'm not knocking it. I'm saying that's fluid resonant bonding. It has nothing to do with quantum things. It has nothing to do with entanglement. The question is, what is it? You've experienced it, and I have experimental evidence, and I have clinical experience about resonant bonding. And this is going to have tremendous clinical implications. We'll see how much we can do today. Certainly, it's going to come up in the workshop. This is a take-home, folks. You want to resonant bonding, if real, presents all sorts of methodological challenges for the geeks in the lab, and it also presents all sorts of clinical opportunities for the folks out there actually trying to help people. In my healing experiments, the treated and the untreated, otherwise known as the experimental and the control groups, I'm putting in tangled just to make you feel safe, but they become bonded. If they're bonded, a treatment given to the experimental group will also result in a treatment given to the control group. We have in science, in culture, all over the place, we have a series of untested assumptions about the way the world works that we rarely give much attention to. They're just kind of given. We don't think about them, we don't reflect on them, we don't question them. Among the things we assume, both in experimental science as well as out there in the real world, is that if you have physical separateness, you have independence. If I'm here and you're there, I'm here, you're there, what happens to me has nothing to do with you. What happens to you has nothing to do with me. And I'm suggesting that under some conditions, whether it's a mouse, a cell culture, or a person, that physically separate units can become bonded to each other, and then what happens to one will happen to the other. What happens to one group will happen to the other group. So what the unstated assumption of all experimental science is that a condition known as locality exists. Locality means in your locale, which is different than my locale, what happens in your locale doesn't affect my locale. So we can take a group of mice, break them up randomly into two groups, do something to this group, have nothing done to this group, and we assume that these two groups are independent. What if they're not independent? What if doing something to this group results in something happening to this group? If that's the case, we're going to do what geeks call type 2 errors. And type 2 errors mean, in English, you think nothing happened when something really happened. Now, I'll give you an example from human trials. Let's say that we have, I'll make up something here, but let's try to go a little bit topical. Let's say there's a new kind of virus circulating around, and we're trying to find a treatment for that virus. And I get a whole bunch of folks, and I could do this, I'm saying folks, but I could also get a whole bunch of mice. I could also get a whole bunch of cell cultures, but let's go with folks. So there's a virus, we'll call it, I don't know, COVID. And we get a whole bunch of people that, we think we have a treatment. And I want to test the treatment. So I got a couple hundred people who volunteer to take the treatment, and they have COVID, and we split them up into two groups, and one group takes my treatment. So I have the magic pill. So I give the magic pill that has my magic formula in my magic pill to one group. And to the other group, I give a placebo, which means they're getting a pill, but there's nothing in the pill. So one group has an active pill and one group doesn't have an active pill. And they all volunteered for the study, and they went separated into two groups randomly. They're getting the active group, they're getting placebos. Now, at the end of a certain length of time, what we're going to do is we're going to compare how sick the two groups are. If they're equal in sickness or equal in health, then we assume that nothing happened, meaning there was no effect of the treatment. It's the same as placebo. What if the physically separated groups are not independent? So this group gets an active COVID treatment that works, and this group, which is non-locally bound to the other group, is also getting the effects of the treatment. They would all get better, and we would say the treatment didn't work. And the treatment didn't work because they all got better. That's a type 2 error. Now, in my mice experiments, and incidentally, this is how I think placebos work. I don't think placebos are psychological. I think placebos are physical bonding, informational coupling of physically separate groups. And I can show you a ton of stuff to that effect. So here's an example. I'm going to show you 2 experiments and then open it up for questions. This is done at University of Connecticut Med School. I have more than 3 cages, but these are treated cages at the bottom. So we have a boatload of cages. We got cages, 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 cages. And someplace or other in the lab, in another, far away from the lab, at least 100 meters at all times, and these were always moved, was a set of control mice, more than 1 cage, but a set of control mice that didn't get treated. These were treated, these weren't treated. We also had a second control group not known to me or any of the healers in the volunteers. And over here where it says labs, these labs are working on the exact same mouse. And incidentally, if you were here on Sunday, it's the white mouse I showed you. Didn't show you a white mouse tonight, but the white mouse I showed you on Sunday. So in other words, we've got a bunch of white mice here with a certain kind of cancer being treated by healers. We've got control groups, more than 1 cage, that are not being treated, and the healers never see them. And we have a second control group we didn't even know existed. And we have a bunch of labs not connected to our experiment between us and the controls. Now, if you believe in locality, what happens here shouldn't have anything to do with what happens there. And if you follow Rupert Sheldrake, for example, he talks about morphogenetic fields. If the healers are putting out a field of healing, and the field of healing is sufficiently large that it extends up into the control group, then anything in that sphere of influence, anything within the size of that field should be affected, which means these labs should be affected. If Rupert is right, and these mice are fixed, and these mice are fixed, then the labs here should also have anomalous cures. But here's what happens. All of the treated cages mice get cured. The control mice that the healers haven't seen but they know exist were cured. And the second control group, not even known to the healers, were cured. And nothing in between is affected. This resonant bonding is not a field. What makes the bond, what breaks the bond, becomes the important question. And this goes to the same question, why do you love your dog Monday and hate your dog Tuesday? What happens? What is the informational coupling? I don't pretend to have the answer. So I could do one more experiment. Lauren, do I have time for one more experiment? This is my favorite experiment of all time. I can say this without equivocation. Resonant bonds appear to be fluid. I'm speculating here. Bonds can be produced by exposure to the healer, the shared experiences among the healees. Bonds can be broken. So again, it's not entanglement. If it was entanglement and I got one atom over here to get mad at this atom, it would become disentangled. They don't become disentangled. Photons don't become disentangled. People become disentangled. Mice become disentangled. Cell cultures become disentangled. This is my all-time favorite experiment. And this is almost drawn to scale. There really were 5 cages filled with mice, and each one of the cages was treated by a volunteer student who didn't believe in healing. I never work with believers because they scare me. None of the 5 students believed in healing. They didn't know anything about it. They couldn't spell Reiki if they needed to, you know, stuff like that. So 3 of the students were not chosen by me. They were chosen by a biologist helping me with this. So 3 of the students were biologists and 2 of the students were non-biologists, and I picked them. And each of them had a cage of mice, and the cages were next to each other, and they were all together on a lab bench. And what I was questioning here was not whether healing happens, but rather am I really teaching healing? So in other words, I wanted to know if we have the effect that you just saw. In other words, my effect on this cage can also produce an effect on that cage. I assumed that if we lined up 5 cages and we had 5 different students treating on the same lab bench in the same lab, if any one of the 5 of these could heal, then all the mice should be cured. I mean, you know, we've seen that before. So the question wasn't, will any of these mice be cured? The question was, what would happen if they took the mice home? And this is a violation of about 75 different statutes. So that's why I'm not saying this out loud, and Lauren certainly isn't recording it. So what would happen if they did it at home? So everybody in this experiment was committed to treating in the lab, coming in and putting their hands around a cage of mice, like you saw in my picture. And they could come in together, they could hang out together, they could do whatever they want to do. They're doing the stuff. And then they went home, and everybody had gotten a cage home that nobody had ever seen except them. Direct from another lab to them, didn't pass go, didn't collect $200. We had a pretty elaborate system, so nobody ever met anybody else's mice. So the question was not whether something would happen in the lab. I assumed that if it happened in the lab, if anybody in the lab could heal, all of the mice in the lab would be healed. But what would happen at home when nobody at home had ever met anybody else's mice? So we had 5 cages going on, 5 different people, and we had a control lab someplace. I'm not allowed there. I never saw it. I'm considered a contaminant. So I designed the studies, and then I have to disappear. But in the building, someplace was another lab where we had, I think there were 3 cages of control mice. The students were told not to go look for the control mice because we wanted it to be pure. And there was also a second control off-site. So we sent some mice farther away to see if distance mattered, or this matters or that matters. So the biologists, actually all the students were told, please don't go looking in any other labs, because if you look in the other labs, you might stumble upon the controls, and we don't want you to stumble upon the controls. We want to keep it pure. And in the right time, at the right interval, at the right number of days after injection, the control mice started to die. And the students said, they're dying? Mine aren't looking like they're dying. And so they looked at each other, and the biologist snuck in because we told them not to go to the control lab. So what did they do? They went sneaking into the control lab. And they went to look at the control lab. They only stayed for about 10 minutes, and then they left. And here's what happened. The check mark means they lived. The X means they died. Now, make sense of this. The biologists, mice, died. They treated them for an hour a day. And they were with each other, and they were sharing and talking about their mice and doing all that. And the control mice were dying until the biologists looked at them. The biologists who couldn't cure in the lab. They went to another lab, looked at them for 10 minutes, and went scurrying out because they weren't supposed to be there. And those mice got cured. They were dying till they were seen by the biologists, and then they were cured. The non-biologists were cured their mice in the lab. Now here's the question. If the non-biologists cured their mice in the lab, and there is this overflow effect, why didn't they cure the biologists who were losers? And at home, everybody was cured. This is my all-time favorite experiment. This took me years to unravel. I think I have it. Maybe not. Partial. But at home, and I'm looking at their logs, they're all hanging out with their mice. They're kind of cute. In the lab, what's going on? The biologists are sitting there with their hands around a cage of mice, with their little white coats on, exposed, as it were, certainly to ridicule. Look, they're the idiots putting their hands around a cage of mice thinking they're going to do something. And in their labs, in their journals, they were embarrassed. So they put on their little white coats and they took out little calipers and measured the size of the tumor. And they did all these other kinds of cute little things, trying to make believe they were scientists. They felt really ill at ease. When they went to the control lab, they went playfully. Bengston said, don't look for the controls. Let's go look for the controls. I mean, that's a good student. You got curiosity to find out what you're not supposed to do and why. But they went playfully. When they're doing their own mice, they're not playful, they're embarrassed. The non-biologists can be playful because they don't give a damn about what other people think about them. So it's not a question of making a field within which there's a sphere of influence. Bonds can be broken, and they can be broken by the tenseness of the biologists. The non-biologists just hanging out, the biologists going to see the control mice are playful, and they can transmit the information apparently in 10 minutes. Or by going there playfully, they tied the control mice into the resonantly bonded group. At home, no such problem. Everybody's happy. We're putting our feet up, we're listening to music, we're doing whatever we're doing, and we got mice on our lap, and we're treating them, and it's kind of fun. They're kind of cute. This illustrates bonding. It illustrates unbonding. It illustrates not belief, but it illustrates that something which will become very important in the workshop, and that will be playfulness. Playfulness and openness. Playfulness and openness produces what? Bonding. Tenseness and embarrassment produces a shrinking and unbonding. And healing will be tied in to all of this. And so the implications of this, I think, experimentally are tremendous. If experimental groups can become bonded together at a physical distance, then we may be misinterpreting experimental results all over the place. So I'll give you an example. This comes from Indiana University Medical School. We did one particular study. We had 6 animal rooms going on at the same time. And we had in one animal room, somebody knowing my technique doing this, and another one, they're not doing the technique, and another, they're waving their hands, and another, so 6 different things going on. I didn't even know there were 6 rooms. End of the study, all 6 rooms, all the mice are cured. And the conclusion was nothing happened. Now, these are mice 100% died, 100% lived. And the conclusion was nothing happened. Why? There's no difference among the 6 groups. If you're geeky, what the analysis that was done incorrectly, incidentally, is a one-way analysis of variance showing what's the difference among the 6 groups. And there was no difference. They're all cured. Therefore, nothing happened. The experiment failed. I mean, that's the craziness. In experiments such as on COVID, if you've got a bonded group, and the question becomes what makes the bond and what breaks the bond. If you've got a bonded group, then the bonded group, you jiggle one, you're going to jiggle the other. Now, the short version here, if I were to map this out, which I know I don't have time, I'm getting placebo effects that exactly match human placebo effects, but I'm getting them in mice. How do you get a psychological effect from that? I get placebo effects in cell cultures. And here comes the kicker. This last one's not published. I get placebo effects in placebos. Now, what I did here is I got the FDA in the States to return unused placebos that they had made. So there's nothing in them. They're to be used in things like drug trials, and there's nothing in them. But they were part, and they were there ready to be called upon. They never were needed. They were stuck back in a pile. I got the pile of placebos, and I sent them out to 2 independent biologists for analysis. And it turns out both biologists found that the placebos are chemically active. The placebos themselves had become bonded to the pills that were made for treatment. So I've got placebo effects in people, in mice, in cell cultures, and placebos themselves. If you're in clinical practice, at least in the States, you guys know the regs better than I do. You get a patient, you come in, you treat them in isolation, and you send them out. You get another patient, you treat them in isolation, you send them out. You get another patient, and this goes on. And we got HIPAA laws and those laws, and I'm assuming Canadians have the same laws, essentially, and you do all that. You're trying to keep your people separate and therefore respect their privacy and respect their independence, and you're going to assume that of a locality that they're not bonded. I submit to you and will submit to you during the workshop that the way to increase strength of effect is to bond your patients together. And the same way that the more mice are in an experiment, the faster they collectively get better. Observationally, but not under a controlled setting, I think the same thing happens with people. I think we're doing exactly the opposite of what we should be doing in clinical practice. I'm not speaking here legally, I'm not speaking about regulations, I'm speaking in terms of outcome of clinical intervention. Resonant bonding matters. This is not casual what I'm putting up here, and will rear its head throughout the workshop. Yet to come, can't be tonight, states of consciousness and mind and awareness as how does that relate to healing? I got lots of functional MRI data, EEG data, double-blind controlled EEGs and functional MRIs. It's reasonably interesting. And then finally, and this won't happen, certainly this will take a while to get through, can we store healing and do it, make it like a battery? So once again, because it is such a cool cartoon, I have to put this up. I get a kick out of it, so tough. Thank you.
Thank you very much, Bill. Thank you again very much. And guys, thank you guys for your questions. We're going to look at some of those questions now. I want to let you know until June 20th of 2020, this workshop is on sale, so you can save. And the 3 days are going to be the 27th, 28th, and the 11th of July. And again, you can get to that from laurenbrown.com. If you want to watch this recording again or share it with somebody, they'll all be here on healthyseminars.com Bengston. So that's how you'll find it. And the replay, both replays will be here, so you can watch them here. And then the link also will take you easily to the registration page if this interests you. So if you want to hear more about this and interact with Dr. Bill Bengston, that's where you go. And then on the Healthy Seminars, any page will have the resource. You can find it easily here too. If you go to the calendar and you're in June, just go to this June 4th date and it will automatically take you to Lessons from the Lab, where you'll see those 2 recordings. Yeah, let me just, in case people don't understand the plot of what we're trying, because Lauren, you and I worked out something that's a little bit different than I have in the past. Instead of having a 3-day workshop, we're going to have 2, a break, and then a 3rd day. And the general idea is you're going to get the techniques, and then you're going to go practice your brains out for a couple of weeks, and then you're coming back to bring it all together. And so it's not, how long can you pay attention kind of a thing. It's an intensive 2 days, and you'll be getting homework.
And so I don't know if I'll give you mice to take home, or you can maybe heal a couple of sick people or raise them from the dead or do something like that, and then we'll come back and then we'll see how we do, what we've done, and where we can go from there.
You'll have a chance to learn cycling and practice it, and you'll be able to order your cotton, so you can charge some cotton as well, that stuff. So
we'll have instructions and handouts, but homework too. So
yeah.
This too will not be for the faint of heart.
So let's do some questions here. So there were some questions from the group. So, and again, you can also raise your hands, guys, but I'll look through what we saw in the chat. I'm just going to go through them here. As the size of a normal untreated tumor grows, the weight of the tumor mass causes devastating internal damage. If these tumors continue to grow until they rupture, what happens related to the internal damage of the tumor growth before there is a cure in these treated tumors? Did you see that in mice?
Well, I mean, you're exactly right in terms of how they die. Without being the intervention, it does all sorts of nasty things internal. It does nasty things nutritionally. It does nasty things to the just inside pressure and all those kinds of things. So is the question, is there lasting effects on the mice after they're cured? And if that's the question, then the answer is no. They're all fine. They live their lifespan. They don't live extra long lifespan, so they hang around for about 2 years. They don't suddenly become 8 years old, kind of a thing. Nothing happens to their longevity, and there's variation in the stages are roughly predictable, but the rate at which it goes is not particularly predictable. And kind of like COVID, some people get COVID and they go, whatever, they sneeze and it's over, and other people are, it's serious stuff, and nobody's really sure the unexplained variants of that either. There's some selection now being thought that it may be related to blood type and this and that and the other thing. But same thing happens in cancer.
How does the observer effect come into play here?
The observer effect, we don't know. The real classical observer effect having to do with, depending on who's in the room, as an experimenter effect, we've never not had cures, but I think the observer effect, not just in terms of presence, but in states of mind, was just illustrated in the resonant bonding when the biologist couldn't cure in the lab. I'm not the first one to discover that. This was first discovered by one of your Canadian compatriots, Bernard Grad, who was the granddaddy, I think, of all healing research. He began the research at McGill University in the 50s and 60s. And Grad also tested skeptical medical students on plant growth and wound healing in animals. And he found that medical students have an effect on plant growth and wound healing. They retard it. Grad's conclusion, of course, was if you're sick, never go to anybody who's been to med school. But that's not necessarily a good and great advice. But I think it's related not so much as a direct result, but rather in terms of enhancing and detracting from resonant bonding. So what you would appear to have as an experimenter effect in the classical sense, I think, is more what are the conditions that make or break bonds.
Okay. There's another one here about, you kind of connected to resonant bonding here, so I'm just looking for it in the chat. Are the type 2 errors anything to do with the yogurt knows yogurt experiment that Richard Bandler did, where they fed one yogurt culture at a distance and the other culture responded?
Yes, that's bonding. And so the interpretation would be there was no difference between the two groups. And that's also, I think, how people, it's identical, the idea of bonding and what are the conditions under which bonding produces non-locality, connection at a distance. And once again, I don't think it's entanglement, I think it's connection and disconnection. This is what the placebo effect is. I'm reasonably confident. I have a really nice design to test that I haven't gotten to it yet.
Perfect. All right, I want to thank again Dr. Bill Bengston. I hope to see many of you at the workshop June 27th, 28th, and July 11th. Again, you can go to the Healthy Seminars page, watch the replays of this. The link is there also, or you can find the workshop at laurenbrown.com. And I want to again thank you very much, Dr. Bengston, and thank you guys for coming in with your great questions.
Welcome. Welcome.
Now we've turned off the recording.